All right. So good morning, everyone, and hello. I'm Vinit. I'm from IBM. It's already written. Though this title appears very fancy, it's basically a VFS module, which provides us a SMB layer on top of RGW. And it's really wonderful to be here on this, especially on this 25th of anniversary for sambaXP and the announcement for Samba Foundation. So it's really good to be here with all you wonderful people. So yeah, let's start. So a simple agenda today. We'll talk something about Ceph Object Gateway, why we do need such a module for SMB or RGW, how we achieve it is using librgw, some details about modules, mainly parameters and few more changes. Then we speak something about implementation challenges that we face, which are bit different than how general POSIX file systems differ from this particular one. Current status, then future scope, and I also recorded a small demo. So without so what is a Ceph Object Gateway? It's basically an object storage interface built, and it provides RESTful APIs for applications to speak with rather Ceph cluster, and it's built on Rados. It supports couple of interfaces, mainly S3 compatible and Swift compatible, so they are each compatible with each other. This is along with it, it provides multiple advantages, scalability and performance wise. Ceph claims to support billions of objects ranging from petabyte to exabytes, and it has supports industry standard APIs like AWS S3 and Swift, and they share a common namespace so that you could read using S3 and write using Swift APIs and vice versa. It supports large-scale deployments, and it provides some advanced features like content filtering right at the storage node, which is helpful for AI/ML type of workload where workloads are very, very bigger. And this is general diagram with respect to how everything glues together and eventually talks with Ceph cluster. So why do we need SMB over RGW? Mainly and foremost reason is legacy application support. We almost, rather every one of us is used to have mounted file system of some kind of other, and our applications are written in that context that we always know there is a file system where there is a network attached or the local file system. So the main purpose, it provides its ease of use for client as well, and it supports legacy applications. So that means any POSIX client, any POSIX compliant client should be able to make use of RGW, that is object store, without modifying their application, without rewriting them, or without learning new commands to talk with it, something of that sort. It bridges protocol. That means S3 has a concept of upload and download instead of reading and writing. So this is something this particular bridge provides us with a. We don't need to again make changes to learn about how upload works and how download works. Then there is a concept of multi-part uploads, upload completions, and everything is shielded, and we could use our normal machines just to use object stores. Most important is file level management. It gives us a hierarchical view which we are more comfortable with to look into. That means there are buckets and there are objects and there are prefixes, but it's really on flat address space. Sometimes it's just difficult to look into it. So this way we could get a standardized ls command we could run, and we could get all the hierarchies and everything. And mainly a familiar access control, so that we could really do a granular access control where we could select directories and put POSIX ACLs on top of them, and it's more familiar to us, it's more familiar to our scripts. So basically the crux is we do not need to change anything. As long as you have POSIX compliant client, it should run as is, with, of course, with some limitations. So how do we provide this is by means of librgw. So what is a librgw? Librgw is basically a full-fledged Ceph object gateway instance. So whenever we load, and it's a loadable library, so whenever we initialize this library, it actually starts a full-fledged instance, which will talk with underlying cluster file system and give us APIs, which are also known as RGW file. Those APIs in order to speak with, or rather allow us to communicate with the object store. It follows the same namespace convention as AWS hierarchical namespaces. That means the top level for a particular user, say suppose user 1, the top level would be all the buckets created by user, then the prefixes like directories, and then the objects, and so on and so forth. librgw provides one additional layer of security apart from POSIX ACL, is that it has its own user credential management. So whenever we are using librgw and accessing objects on top of object store, we configure essentially a user which will be using this, and its user credential will be always used in order to perform every operation. It supports all sort of standard POSIX operation like open, close, directory, all the directory related operations, and chmod, lsmod, everything. Sorry, not the lsmod. Bad part on my end. But yeah, it does come with some limitations. It still do not support any sort of advanced ACLs like NFS v4 or NT ACLs. It has directory renaming is somehow prohibited. I mean, it's not that it's not possible. Directory renaming is possible, but in object store, directories are mainly prefixes and they are not directories. So to say dir, example, dir slash is not actually directory, it's basically a dir slash named object, and the key would be dir slash to access it. So if we have a multiple objects with the dir slash is prefix, object store treat it as a prefix, not, it does not necessarily fall under that particular directory, since there is no directory at all. So even if you able to rename dir slash, it will just rename the object which is dir slash. The rest of the objects like dir slash a.txt would still stay the same. So that's why librgw do not recommend, I mean, though it is there, we can definitely rename, but they refrain it from renaming, I mean, or at least it's not recommended to rename. And the major limitation is random write. So we cannot have any sort of random writes in RGW. It has to be full sequential write from top to bottom. The reason is simply it's due to it's an object upload call, and it does not have concept of even modify write, or rather read, modify, write, something of that sort. So therefore, all the application which requires in-place editing like editors or our tar file systems, or any application which relies on random writes, won't be able to operate on this particular solution. So our VFS module is known as VFS Ceph RGW, and it has few dependencies. It's mainly depend on librgw2 devel, and it is generally packaged along with most of the distribution. We have provided a build configuration option with enable Ceph RGW, and also we have made sure that configuration script automatically detects presence of librgw2 and other dependencies, and if it's met, the module will be enabled. And let's talk about module parameters. So path is, ideally we do not make use of path anyways. I mean, it's a bucket, so there is no path. but we just keep path as slash. But it can be anything, but it won't make any difference to operation. AIO write size should be 0, so that means it would be always go into synchronous mode since we do not have any random write support. So we prefer it to be AIO write size as 0 so that it will be always synchronous. And VFS object is basically Ceph RGW, and rest are almost the name suggests bucket would be the name of bucket to export as a share. User ID is the RGW user ID which has a required credentials to access that bucket. Access key and secret access key are the keys which are created during the RGW user creation. Those need to be specified here. And the config file and keyring file, which are pertaining to Ceph, are mentioned here. So there are default paths to it. Most likely they are them. But if at all there's a difference, then those can be mentioned as well. And librgw also provides something called a debug support on their own, where if you turn it on, it will dump all the content into log.smbd, or rather whatever the log which your binary is running while linking to it. And we also use a force parameter in module, and which is VFS mkdir use TMP name. For the same reason which I described in earlier slide, that RGW does not like we to rename directory. And this particular parameter controls if, by default, if this is off, and Samba uses temporary directory names to create a directory, and then it actually renames it to the one directory that you use. So this particular parameter, when set to no, make sure that Samba do not uses a temporary name so that we don't have to come across the directory renames. So while implementing this, we did met with few challenges. The first and far most important is basically all paths are relative to bucket. So there is no slash or there is no mounted file system. So every access that we have to make, which are name-based accesses, then those has to be, those starts with after the bucket root. So if bucket is say demo bucket, then an object is A, then we'll just get A. And again, we do not have a concept of special names like dot or slash. So they will be, so way we handle is we actually pass them out, and if we detect that the names requested are dot and slash, then we assign them as or rather we treat them as a bucket root, and then we perform operations on root of the bucket. It contrary to other file systems, these RGW works on handle-based operations. So we do not receive an FD, but we receive a handle, which is an opaque structure. And there are a couple of ways to get this handle. Mainly RGW lookup and RGW create. Both provides us the handle, which is handle fh *fh. And those are the only way, but now here's the complex part, that even though they provide a handle, it does not mean the underlying object is open. So in order to open that, we have to make call RGW open. So this is something different that we generally use. We generally just open or create, and we are known to sure that return FD is always open for the use. But that's not case here. So we have to store that handle and later on call RGW open to open it. We talked about RGW lookup. One interesting case of RGW lookup is with directory open. The directory open as such is not supported with RGW open. For directory opening, we have to call RGW lookup, and we cannot have slash as a trailing character to it. So we have to make sure that we strip that particular character, and then we call up RGW lookup and store its handle. Then we use that handle further in FD open and all the directory related operations. So directory creation is, there are two APIs technically which we can use. One is RGW create and other is RGW mkdir. So initially we did try to use RGW mkdir, but It has certain changes. I mean, mainly librgw was developed as a need or as a support for NFS over RGW. And so it is more influenced towards using NFS style syntaxes and calling mechanisms, or even the, what I say, semantics for operations. So the directories created with RGW mkdir do not possess any timestamp. So that's the reason we skipped RGW mkdir and we switched to RGW create. And that's how we, only thing is, RGW mkdir automatically appends the trailing slash to the end of directory to mark it as a prefix. But in RGW create, we have to check whether it's a directory create mkdir, and then we have to add a additional slash to make sure it's a directory. And I already explained directory open. File open is same. RGW open requires an handle obtained from either lookup or RGW create in order to work further upon. Only then it will mark that particular handle as open, and then we can perform any read or write operations on top of it. If it doesn't, then we won't be able to operate on top of it. And the most interesting challenge that we face for till now is basically directory listing, and it's a bit tricky to use. So as we could see here, in API itself, there are two important things. One is it's a callback based, and other is a token based. So and basically it's driven using a token and as well as values of return value of callback. So by design, RGW reader, I mean, obviously it can list n number of objects. I mean, there is no limit to it up to whatever object store specifies. But at a time, it could return as max as 1,000 entries. And this is by design as of now. So therefore, they have provided these mechanisms to make a continuation calls to read dir2. So what we have done to handle this is, since our VFS reader requires a single, for every invocation of VFS reader, we supply one directory entry back. So in order to handle that, what we do is, in the time of open directory, we allocate a buffer of directory entries, which is currently 100. We just thought 10% of 1,000 should be good because it won't put log, rather, if the objects bucket is smaller or the number of objects are less in that particular directory, then it won't put much strain on resources. So we started with 100 directory entries of object, or rather directory entries, and we control it using two variables, or rather two pointers. One is top and other is of course bottom. And in FD open, we allocate this array and we reset all the variables. And during the actual read dir call, we call it once, and then basically once the callback read dir will fetch the entries from the backend, and it will store it inside its own cache, and we'll start calling this callback. The callback operates like this: that if we return true, that means we are done with all the. Sorry, just let me check once again. Yeah. So if we return true, it will stop the callback, and it will say I'm done with the callback, and all the entries will be listed. If we return false, then it will keep giving me one entry at a time, and that many number of times callback will be called. So we store all these entries into this particular array, and then once we have reached end of our array, then we start return. Then we break from that loop, then we return back one entry, and whenever we finish with whenever we finish with serving all those entries, stored entries, then only the next directory entry, next call to RGW read dir2 will be called. And for that purpose, for every callback, we store the token, which is essentially the last name which we retrieved, and then we use that token to pass to RGW this particular call, so that we'll start getting the new entries after that particular token. So this is just the sort of biggest challenge that it had. So current status, and this current status pertains to the MR that currently we have, and it supports basic operations like open, at, close, and read, write, rename, unlink, stat, lstat, and fstat. It also supports all the directory operations, open, close, read and rewind, etc. Other operations like set and get xattrs, fn times, and dos attrs are supported. Currently, we are testing with a server which is running CentOS stream with Ceph tentacle running on it, and everything is out of the box. I mean, it's not any modified version or custom version. And we are using client as Fedora 42 package SMB client as well as Windows 10 workstation. And currently, we are just rudimentary testing, like reading and writing objects of various sizes and creating 1,000+ files or folders, nested structures, something of that sort. And we also mix up with creating files and folders using AWS, CLI, and vice versa, something of that sort, to cross-check if they interoperate each other and they provide whatever result we are expecting. So we do have our upstream MR, and authors are me and my colleague Shahar. So Shahar is also continuously helping me with reviewing whatever code we write. So please, we'll request everyone to get into and please try to check it out. Some future scope and limitations. The far most important is basically making our module at par with NFS RGW FSAL module. So currently it has implemented all necessary operations. We are still a bit behind due to other work, but yeah, I mean, that's the future scope, that we need to make module at par with RGW FSAL. Then, since I believe I mentioned this, is librgw is essentially a full-fledged client in itself. So whenever there are multiple number of connections start opening, there will be a new copy of client getting loaded. So whenever there is a scalability, whenever we look for scalability, then there will be time where it will start overwhelming system resources. So as we have something like a proxy for our lifts FFS module, so maybe we could think of having proxy module. I do not know whether it's possible or not at this stage, but going ahead or going future, that could be a chance of supporting more scalability using proxy module like we currently have for lifts FFS. And limitations are, so basically our module inherits all the limitations from librgw, which are random write, directory renames, and the main thing is there are no change notifications available in RGW. So if we are listing if there are multiple millions of objects and we are listing, and if there is a change in between, then we won't be able to know until we relist it everything again. But this is change notifications is a rather main limitation from the librgw itself. We have a couple of known issues. Currently, renaming file or directory triggers a unlink in backend. So this is actually very funny, but we haven't found a root cause yet. So at the background, what it does is actually it copies the object gateway basically, or the object store, copies your object with a new name and then deletes the old one. So with the debug logs, the debug parameter that we had, so we tried to debug it further and we could see that it's copying the object correctly, but somehow that object is not getting created. And later on, it just unlinks the original one, understanding that it has already created an object. So we are trying to get it fixed with the help of librgw. Surprisingly, it doesn't shows up on their test framework, but it's appearing somehow in only through our test APIs or through our module. So before starting this effort, I have written a small binary which will make use of librgw to test out all the operations which we have. So even there itself, this is something happening. So currently, this is the known issue for module. and inconsistent callback for get xttr. Get xttr is also a callback based API. And we discovered this pretty recently that it's not always getting a callback. For every time we call, we may or may not get a callback. So I'm really not sure what's happening, and I didn't got much time to look into it in much depth. But due to this, the file timestamp differs, because even if we set it properly, it does not able to get it, and then it will just show the basic our epoch time. So that's the current known issue. And to be honest, it just I really discovered it pretty late in the development. So I have prepared some short demo, which will do all these things like creating objects using AWS API. We'll read objects through SMB client, write files, will list directories. Then we create some nested structures of files. We'll browse share basically, and we'll run MD5 sums to check whether we are having consistent data or not. So I'll try to run it from here, but I'm not sure whether it's. Let me know if it's a smaller one. I'll just run through video. Okay, so this is how it will look like. So I'm exporting demo bucket with user one, and these are just access keys and etc. Running SMBD. I have written a small script to just automate things instead of typing commands and keep switching tab altogether. So this is all happening on the SMB or RGW module. So this is the script I was speaking about. It's just a simpler script. I mean, it just keep doing things on its own. So currently I'm uploading a 1 gigabyte of file as a file G object in demo bucket. It's listed. Now back to SMB client. You could see that. I'll try to get it on the local storage. Come out. I'll just check the MD5 sum again, which matches with the original one. And now I'll try to write it back. Go out. Now I'll read it. And there it is. So I'm using AWS CLI and SMB client just to make sure that it's interoperable and they reflect each other's. And so MD5 sum matches each other. And I think now I'll do a big ls to, yeah. So these are 1000, I think there are 1200 plus files created, or rather the objects to be, of all 0 size. And I'll just create few directories and nested directories, maybe put file in it. I think that's done. Right, I'll just pause for the sake of it. Yeah, I have that much. Thank you very much for listening to me.
For this discussion.